Alrighty, it is time to talk about one of the more mathematical subjects that we have covered so far, and that is the subject of matrices. Please bear in mind that I am a software engineer. I am a computer nerd, not a math nerd, so bear with me as I give my naive best explanation of what a matrix is, and then we'll cover some more practical uses for a matrix. And now we've been using matrices already as part of the drawing class, kind of in the background. Every time we did a rotation or a scaling or a translation, we were using a matrix. Although the math behind that was pretty much hidden from us, all we had to do was make a call to like a rotate function or something like that. But let's go ahead and talk about what a matrix is first. Uh, it is basically a structure that holds uh, what you can consider a coordinate system, basically. If you think of a coordinate system like in the terms of X, Y, and Z, you might have something like a let's go here and draw X and Y, and then Z might be going into the image like this. So X is up, or sorry, Y is up, X is in this direction, and then Z is kind of like inwards. If this was, if I could actually draw a three-dimensional shape, this is sort of like a rectangle like this, or a cube like this, and we're seeing on this axis, this is the Y, and this is the X, and then kind of going into it like that. This is the Z here. Okay, so as I was saying, we have this coordinate system, and each axis on this coordinate system is defined by a vector. And as we said before, a vector, we did some vector math earlier. A vector is basically a set of numbers as opposed to a scalar, which is a single number. A vector is a set of numbers like x, y, and z, or red, green, and blue, or some other set of numbers. But in this case, it's x, y, and z. So if you look at this, each of these axes is whatever is itself a vector. We start at position 0 in space, and we go to some other position in space, and that is a vector. As we know, each vector is a set of, in this case, 3 values. So let's go back here and look at this structure. Um, we're going to fill this structure out with these 3 vectors. There's vector 1, vector 2, and vector 3. Vector 3. Trying to make that look like a 3, but anyways, vector 3. Uh, and like this, we could say this is vector 1, this is vector 2, and this is vector 3. So vector 1 is the x vector, vector 2 is the y vector, and vector 3 is the z vector. So let's define a coordinate system. In this case, x was pointing off in that direction, so it would be 1, this is x, this is y, and this is z. And the other two would be 0 because they're not they're not going anywhere. It's not pointing in the y direction, or it's not pointing in the z direction. It's pointing completely in the x direction. And the same for vector 2 is pointing up, so this would be 1, 0, or 0, 1, 0, 1, 0, and same here, 0, 0, 1. So we have a vector, one pointing to the right, one pointing to upwards, and one pointing inwards in the z-axis. So hopefully that's all clear. Now, as you see in these 3 by 3 matrix, we defined a coordinate system. We defined exactly what we drew here, a coordinate system. Now we could hypothetically rotate or scale this coordinate system, say 45 degrees, and we get something like this. That would be a coordinate system in itself. And this would be the new y, and this would be the new x, etc., etc. That would be the new z. We may not call them that, but anyways, we're rotating, we may rotate it and scale it so it's like this really big thing. It's like this, going way off screen, etc., etc. Or we could shear it and it'd be like, I don't know. The X would stay the same, but the Y and the Z would be both like askew or something. And those are some of the kind of things we can do with matrix math. So why is this useful? Well, say we had a whole bunch of points in a 3D object, or a whole bunch of pixels in a bitmap. We don't want to have to worry about scaling and rotating and doing all that math for every pixel. We just do the math on this coordinate system, and then we go apply this matrix to all those points. So hopefully I've said what a matrix is. And in the next video, we'll look at how to use the matrix class in Howler. So hope that was clear. Thanks for watching, and talk to you next time.